Right, let's do a quick tutorial on conversions between grams and moles, starring molar mass. Remember that molar mass is the only kind of conversion we do between moles and another quantity that depends on the identity, at least at this point in time. So let's dive right in. How many moles are in a 12.6 gram sample of Fe2O3? So the number that you're given, which is what you're going to start with, is 12.6. So we know that we're going to have 12.6 grams to begin. Think of this over 1 if that helps you. And then you can format it like this. If grams are on top, then grams are on the bottom. We're going into moles, so that's on the top. Everything is relative to 1 mole. Now, visually different, mathematically the same. You can also write it out this way. In order to do this math now, you need the molar mass of Fe2O3, which is our conversion factor between grams and moles. So as a quick reminder, we have 2 irons. Iron's number off the periodic table right here is 55.85. We're going to multiply that by 2 because there's 2 of them. Oxygen's number is 15.99. We're going to multiply that by 3 because there's 3 of them. And then when I do that math all together, I'm going to end up with 159.67. So that is your mass of 1 mole of Fe2O3. So then that number goes down here, 159.67. So then you look at these and remember that when you're multiplying fractions, you multiply across the top, which is 12.6. times 1, you multiply across the bottom, 1 times 159.67, and divide. So we're going to do 12.6 divided by 159.67. You'll put that in your calculator and you'll get 0.079. Don't forget your unit, which is moles. Don't forget your identity, which is Fe2O3. Let's try another one. Going the other way. What is the mass in grams of 0.258 moles of BaOH2? So we're going to start with what we're given, which is 0.258 moles. We're going to set up our multiplication here, okay, or you can write it out this way if you want to. That is just personal preference or maybe teacher preference. Moles is going to go on the bottom because that's what we're getting rid of, and all of our conversions are relative to 1 mole because the mole is the central quantity in chemistry. Then we're going into grams, so that goes on top. So again, we're going to need our molar mass of BaOH2. So here's how you calculate the molar mass of BaOH2. Here's your barium, plus you have 2 oxygens and 2 hydrogens because that 2 distributes within, and so that's 171.34. So our 171.34 is going to go on the top, and so then we're going to multiply across the top, and then there's really no bottom because it's all 1. So 0.258 times 171.35, and we're going to get an answer of 44.21 grams. Don't forget your unit and your identity. Hope that helps.